Hello, welcome to class. So we want to solve this question. If you look at it, it looks so complex. So what I'm going to do is, I will use this side to simplify each of these terms. When I finish, I'll just come and bring it here. Okay? Now, there's one of the laws of indices that says when a number or a term is raised to power of a negative number, a negative anything. Let me use negative b. That this thing is equal to, because of the raised to power of a negative power, this negative is 1 all over, then this a raised to power of b is a law in indices, a law of indices. Okay? Right, and then there's another thing. If I have a over b raised to power of a negative number, a negative, let me just use c for instance. This thing, if we apply the same thing we did here, we're going to have 1 all over a over b raised to power of c. Are you getting it? Then there's another thing I want you to note. When you have 1 over a fraction, it will give you the reciprocal of the fraction. You turn the fraction. How am I sure that this thing is true? Okay, let me see. If I have 1 over a over b, it's the same thing as saying 1 divided by a over b, which is the same thing as 1 times, remember the law of division of fraction. So you turn it, you have b over a. Okay, so that I will have 1 times b is b over a. So we have agreed, or we have concluded now, that 1 all over a over b is the same thing as b over a. So if I carry this thing now and apply it here, so this thing will be the same thing as saying, you've gotten this? Okay. This will be the same thing as saying the reciprocal. Let me continue here. B over a raised to power of c. Right? Good. So you can now go further. This is the same as b raised to power c over a raised to power c. This is b raised to power c over a raised to power of c. Because this power here, because of the bracket, applies to each of the terms of the fraction. Is that clear? So with this thing, we're going to use it to answer the whole of this question. So when I get to anyone, I'll just quote the law we used and put it there. So let's start. Start with the first. I have 1 over 2 raised to power of minus 3. Which of these looks like this one is this one? So remember we said when a fraction is raised to power of negative exponent. So what I'm going to do, I'll take the reciprocal of the fraction. So this will turn up, this will go here, this will come down there. That is b over a. Then raised to power of only the c. The negative sign will not be there again, because the negative sign has given room to that the reciprocity of the fraction. Okay, so that's what I'm going to do. If I do it here, this negative will turn, this will now be 2 over 1. Are you with me? 2 over 1. And you know 2 over 1, any number over 1 is the same thing as that number. So 2 over 1 is the same thing as 2. So I'll have 2 raised to power of 3. I hope you're understanding it. Compare this with what I just did here. So 2 raised to power of 3, that's what everything here has reduced to. This division divided by, come to this one. If we do the same thing, the same method again, this is negative, so we turn it. If we turn it, we are going to have 4 over negative 3 raised to power of 2. Okay? Then close this one. Divided by, come to this one, 2 raised to power 3, so this is a positive. We can still leave it like that. When we want to, the next step, we will now simplify further. Divided by, do the same thing here, take the reciprocal, that will be 2 over 1, right? Which is the same thing as 2 raised to power of 4. Close it, then the big raise, negative 1. Okay, so let's start the simplification. Here I will have 2 raised to power of 3. 2 times 2, 4. 4 times 2, 8. This is 8. Divided by 4 raised to power of 2. 4 times 4, 16. I have 16. All over. Minus 3 times minus 3 is 9. Because minus times minus. This is minus 3 times minus 3. Minus times minus is positive. 3 times 3, 9. So I have 9 here. Are you getting it? Alright. Divided by 2 raised to power of 3 is the same thing here, 8. 8 divided by 2 raised to power of 4. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. I have 16. 16. Okay. So we'll go further. This is 8. Remember, when you are dividing the fraction, you change it to multiplication and take the reciprocal of the fraction. So this is the same thing as 8 times 9 over 16 divided by, this one is 8 divided by 16. Are we getting it? Okay, so 8 will go here 1, 8 will go here 2. So I have 9 over 2 here. Meanwhile, remember that all of them are still outside. Divided by this one, 8 will go here 1, 8 will go here 2. So I have 1 over 2 raised to the power of minus 1. Are we getting it? So let me continue here. We have our brace 9 over 2. This division will change it to times. Times, we take the reciprocal, 2 over 1. Then we have minus 1 here. This time is minus 1. So we cancel all these 2. I am left with 9. 9 over 1 is the same thing as 9. So I have 9. Then the outside, minus 1. So using the law of indices, this is the same thing as 1 over 9 raised to power 1, which is the same thing as 1 over 9. Is that understood? Very good. So that is how to solve this kind of question. You apply the law of indices. So understand this law, and anywhere you see something like this, you apply the law and do it. I believe it's clear, right? Alright, so in this particular question, there's some things we also I will explain here, then we'll just apply it here. And that is, if I have square root, this is square root. Square root of a squared. No, I will not put 2 here. It will be like a tautology in English. The way we have tautology, so that's the way it will be. You put 2 here again in mathematics. Square root is already 2. Okay, so when you have square root of a number that is raised to power 2, this square, we cancel out this thing. It's the same thing as that number. Exactly. If I have cube root of a number or a term that is raised to power of 3, cube root and raised to power of 3, this cube root will knock off this 3. It will still give you a. If I have fourth root of a number that is raised to power of 4, this fourth root will knock off this fourth root, return the number as a. So we're going to use it here now. This is a square. So if I like, I can express this thing as square, or you can solve it with the normal mathematics that you know. Square root of 9 is 3. So, or I can raise it to power of 10, anyhow you want to do it. So square root, this, I can write this as 3 raised to power of 2, right? 3 raised to power of 2 is 9. Okay, so this one square. Or better still, let me just go straight so that it will not confuse us. What is the square root of 9? The square root of 9 is 3 plus, this is the square root. This is raised to power 2. Remember, everything here is assumed to be like a now. Everything here raised to power 2. So this one will knock off this. Are you getting it? So when this knock off this, I will be left with root. Okay, let's go to the next one. This is cube root. raised to the power of 3. So this cube root will knock off this. I'll be left with only this term inside here. And that is 2 minus root of 11. So we can now simplify. So I have 3 plus, this is root 11 minus 3. Okay? Plus, this is 2 minus root 11. Okay? These 3, okay, let me bring it forward. But note, if you have positive or negative, positive of a number and the negative of the number, it will reduce to 0. If I have minus a plus a is equal to 0. So if I apply it here, this 3 is a positive 3, this is minus 3. So this 3 can actually cancel out this one to be 0, okay? This is plus 11, and this is minus 11. This can cancel out this one to give you 0. So what we are left here is 2. So our answer is 2. Alright, in this question, let's solve this. What we will do, there are so many ways to solve this, but in this particular video, how we want to do it is let's make this fraction here a single fraction. What do I mean by a single fraction? Let it has one denominator. Let it has a common denominator. So it will be like in one term. You know, it's two terms here, 1 plus a term. So let me make it a single fraction. Why I'm writing what I'm writing. Okay, so I'll bring down this one the way it is, x over x squared plus 2 square root of, this is like over 1, LCM of 1 and whatever is still the same, 4x squared. Okay, 1, because I can call this over 1. 1 divided this is 4x squared times 1. I'll have 4x squared here plus 4x squared divided 4x squared is 1. 1 times this will give me the whole of this thing as x4 plus 4. Okay, then equal to this x plus 1. Alright. Now I want us to note something. This thing can be is it factorized? Let's look at something. You know, if you have x plus 2 squared, which is x plus 2 times x plus 2, will give me x times this is x squared, this is plus 2x, this is plus 2x, and this time this is plus 4. Okay, so I have x squared plus 4x, then plus 4. If you look at it, this is looking like this. Having simplified this, I have this. So if I rearrange this thing I have here to make the highest power to stand first, I have x raised to the power of 4, then plus 4x raised to the power of 2, then plus this 4. Okay, now I have seen that the highest power is 4, here the highest power is 2. So what I will do, the same expansion I did here, I can raise this thing to the power of 2. That is, let me expand x raised to the power of 2 plus 2 squared. You see, it will give me the same, it will give me exactly this. Let's do it. X raised to the power of 2 plus 2 times x raised to the power of 2 plus 2. X times x squared times x squared will give me x4. This times this will give me plus 2x squared. This time this plus 2x squared. And this time this will give me 4, which is x4. This plus this will give me plus 4x squared plus 4. So you see, this is exactly the same thing as this. In other words, this number, the whole of this term has this, the simplification of it or factorization of it to be this. So meaning that inside here I can replace it as this. Is that understood? Okay, so I'll continue. X over x squared plus 2 square root of, so instead of writing this, I'll replace it with this x squared plus 2 squared all over 4x squared, okay, is equal to x plus 1. Alright, let me clean it so I can use it to explain. Now, let's look at this. X squared plus 2 all raised to power 2. Remember what I explained in the other number. This is square and this is squared. So this square will cancel out this square. We are left with x squared plus 2. Let's go to the denominator. I have 4x squared. Square root. Square root of 4 is 2. Then square root of this square will be only x. So the square root of this term is this one. So that I have x all over x squared plus 2. We've already done simplify this thing to have x squared plus 2 all over 2x. And equal to our x plus 1. Are we getting it? Okay, so this term here is exactly as this term here. It can cancel it out, right? S can divide itself 1. S go into x. We are left with only 1 over 2. Okay, so we have 1 over 2 is equal to x plus 1. We are looking for x. We want only x to stand alone. So x, this implies that x is equal to this plus 1 will go to this person. So it will be 1 over 2 plus 1 coming to that side will change to minus 1. So 1 over 2 minus 1. Half minus 1 will give you negative half. Is that understood? So the answer for this, our x here is equal to negative 1 over 2. To solve this one, this square root problem, we'll start from the smallest, the innermost one, that is this one. We're doing it and we're coming out till we get to the outermost part. So we'll start with this. Square root of x raised to power 8. So what I will do is to make this 8. 8 can be raised and can be written in raised to power. So 8 is the same thing as saying, this is the same thing as x raised to power of 4 raised to power of 2, right? 4 times 2 is 8. So if we can write this thing like it is, it means that using what I explained in the previous questions, this is square root and this is raised to power of 2, so it can knock off. We are left with x raised to power of 4 here. So meaning that the whole of this thing has been reduced to x raised to power of 4. So if I come to the second square root, the second square root is 48 raised to power of 4. So plus everything here we have solved it and it has been reduced to x raised to power of 4. So this is x raised to power of 4. So now these two terms, they are the same thing. This is x raised to power of 4. This is x raised to power of 4. So this is the same thing as saying 48 oranges plus 1 orange. You know, this is 1x raised to power of 4. So it will give us 49 x raised to power of 4, right? So it will now come to this point again and write it in a square form, raised to power of 2. So this is the same thing as square root of 49 x raised to power of 2 raised to power of 2. Are you getting it? Okay, so we'll do square root of 49 is 7. So this raised to power of 2, we now call this to be only x raised to power of 2. Do you understand it? X raised to power of 4, square root of it, this is 2, so it will knock off the 2. We are left with x raised to power of 2. That's what I did here. Okay? Fine. So the next thing we are going to, so everything here, the whole of here has been reduced to 7x raised to power 2. So when we get here, we'll not put these things again, we'll carry this and put it here. So we'll go to the final square root. So this final square root is 18x squared plus all these things has been reduced to 7x squared. So they are the same term, so you add them. So I'm going to have 18 plus 7 is 25. 25x squared. So this one is simple to do. Square root of 25 is 5. And this knock off this, I have only x. So everything here has been reduced to 5x. Alright, this question is a number basis question. Okay, so the question is telling us that x is equal to this and the same x is equal to this. In other words, if we can find what our n is, what's the meaning of n, we can solve this thing. So to do that, we express these two terms in base 10. Express them in base 10 since they are the same thing, xx. So this simply means that 54 base n is the same thing as 47 base n plus 1. Okay, so let's express this in base 10. You remember how to express in base 10? You start from back 0, 1, 0, 1. Alright, so we start 5 times n raised to the power of this 1. 5 times n raised to the power of 1 plus 4 times n raised to the power of 0 is equal to, come to this side, 4 times, I will use bracket because it's two terms like there, n plus 1 raised to the power of 1 plus 7 times n plus 1 raised to the power of 0. Now, even in the laws of indices, one of the laws says that when any term that is raised to the power of 0 is equal to 1. So any term, any number, alphabet, whatever that is raised to the power of 0 is 1. So that will help us to reduce some things. For this one, 5 times n raised to the power of 1 is n plus 4 times n raised to the power of 0 from that law is 1. This is equal to 4 times n plus 1 raised to the power of 1 is the same thing as that. Then plus 7 times everything here raised to the power of 0 is 1. Is that understood? Okay, so we'll continue. 5 times n is 5n is equal to 4, plus 4 times 1 is 4 equals to 4 times n, 4n, plus 4 times 1, 4. Okay? Plus 7 times 1 is 7. So what we do now, we collect like terms. 5n will be here, 5n. This 4n, there's equality sign, so if it crosses to go and meet this 4n will change to minus 4n. So this will be minus 4n is equal to, this is 4 here, 4. This is plus, okay, we can even add it. These two numbers can add themselves. 4 plus 7 is 11, right? So this is 11. So this coming to meet them will be minus 4. Is that understood? Alright, 5n minus 4n will give us n is equal to 11 minus 4 will give us 7. So we have established that our n is equal to 7. Okay, so now, so meaning that this means 54 in base 7 and 47 in 7 plus 1 is 8. So 47 in base 8. So you choose any one you want and change it into base 10. That is what your answer is. So let me pick this 54 in base. Let me continue it here. So 54, n is no longer a hidden something, it's no longer a variable, it is now a constant 7. So base 7. Alright, so we now do the normal. Here from here you can solve it from here. From here like this you can solve it. You can even put your n here to give you answer, but let's just continue. Alright, so I have 5 times 7 raised to the power of 1 plus 4 times 7 raised to the power of 0. Okay, 7 raised to the power of 1 is the same thing as 7. So 5 times 7 is 35, right? That's 35 plus 4 times 7 raised to the power of 0 is 1. So 4 times 1 is 4. So if I add these two, I'm going to have 39. So x is equal to 39. If you want to be sure, you can also try this. If you do 47 base 8, you know this n is already 7, so 7 plus 1 is 8. If you do 47 base 8, change it to base 10, you will still land yourself in 39 to show you that these two numbers, they are equal. Alright, so to solve this question, let's have an understanding of average. Average is equal to the sum of the numbers over the number. There is a counting number, the number of terms you have there. Okay? Alright, so that's what it is. So now we have x, that x is the average of these two numbers, meaning that x is written as m plus 9 divided by 2 because there are two terms. Is that clear? Y is equal to the average of this and this, so meaning that y is 2m plus 15 divided by 2. Okay? Then for z is the average of this, meaning that z is written as 3m plus 18 divided by 2. Okay, so we have gotten what x, y, and z, how it's written in terms of m. So now for us to find the average of x, y, z, we do the average of these three. That is, do this plus this divided by 3, 1, 2, 3. So that's what we're going to do now. I have the average is m plus 9 over 2 plus 2m plus 15 over 2 plus 3m plus 18 over 2, then divided by 3, because there are 3 times 1, 2, 3, so divided by 3. Okay, so since each of these terms they have 2 here, even if I make this in a single fraction, you see that it will have a denominator of 2, so that 2 you can bring it down to come and multiply this one. What I mean is that if you have something over a fraction over another fraction, these two denominators can multiply themselves to give you 3 over 4. Okay, so I will use that knowledge now here, so that I will have everything here. That's m plus 9 plus 2m plus 15 plus 3m plus 18 is all over the whole of these two. Just pick one, multiply it by this to give me 6. Okay, so I have this. So the next thing I'll do is to simplify, to collect like terms. Simplify it by collecting like terms. So I have m plus 2m will give me 3m. 3m plus 3m will give me 6m. So I have 6m here plus 9 plus 15 is 24. 24 plus 18 is 42. So I have 42 here all over this my 6. So to simplify further, you see we can get 6 inside here. We can factor out 6 here. So if you factor out 6, I have 6m plus 6 in 42 is 7 all over this 6. So that this 6 will cancel out this 6. Are you with me? So if it cancels out the 6, we are left with only m plus 7. So the average is equal to m plus 7.